Hi, so in addition to your practice test, I have prepared this long test 2 sample, so you will have more exercises as you prepare for your upcoming exam. Let's begin by evaluating or by doing question number 1. Evaluate tangent of x dx from 0 to pi over 2. So on your test, you may be given in instances where you have to solve a definite integral, or there are also some questions that you have to you have to solve an indefinite. So you make sure that you know how to do those kind of things as well, and you're prepared to do them. Okay, so let's proceed to number 1. Evaluate tangent of x dx from 0 to pi over 2. So to do this, we will have to write tangent as sine x over cosine x dx. Okay, then copy the limits of integration. So you're just rewriting tangent in terms of sine and cosine. And then you will have to do u substitution. So you would let u be equal to cosine x, and then therefore your du is equal to negative sine x dx. Now, since I'm changing or I am doing u substitution and this is a definite integral, that means that I also need to change the limits of integration. So make sure to change the limit of integration here as well. So now, because we let u to be equal to sine of x and the limits of integrations is in terms of x, then we would also need to compute for the new limit of integration and now in terms of u. Okay, so let's do from here. Now, let's begin by plugging in x, this x value here to here. And then we compute for the u when x is 0. Okay, so when x is 0, you have cosine of 0, and cosine of 0 is equal to 1. And then you have cosine of pi over 2, that is when x is equal to pi over 2, and cosine of pi over 2 is equal to 0. And so using u substitution, now make sure when you change the variable to u, you don't mix your x and your u. So we let your x, your cosine x dx, your cosine x to be u, and then you would then have to write this as u, that's your denominator, and then this sine x dx here is actually just equal to negative du. So from here, I could move this negative sign to the other side of the equation. So I'll have negative u equal to sine x dx. All right, so that means that this sine x dx here is just negative du. Okay, so you have negative du. That's for the sine x dx. Then you change the limits of integration. So instead of 0, now from 0 it became 1 when u is equal to cosine x. So this is now from 1 to 0. Now, if you look at the limits of integration, you have 1 here and then 0 here. So you can invert them or you can interchange them. When you do that, you make sure to also negate it. Okay, but then there's a negative sign here. Okay, so that means I could take out that negative sign, and then there's 1 to 0 here, 1 over u du. But then if I'm going to invert this 2, that would just be equal to the negative of the negative. So that makes it positive. So that will now be the positive integral of 1 over u du from 0 to 1. Now, before you integrate this, if you look at the new expression, if you plug in 0 to the denominator, you have 1 over 0, and that makes it undefined. So that means that this integral here is actually an improper integral. Okay, this is an improper integral. This is a type 2 improper integral where the denominator here becomes 0. So that means to solve this, we will have to write this as limit. You would have to change that 0 here. You would have to change that to a constant. So that becomes a, for instance, and 1 over u du. Now, this a here, you would let that a approach to 0. And then what's the sign? It is from the right. So if you kind of look at this one, that interval, that is the interval from 0. So if you look at the number line, it is from 0 to 1, right? Now, you have an a here, that is your a, and you want this a to approach to 0. And then to know what the sign is, you look at where a is coming from as it approaches 0. So a is coming from the right side of 0. That's why we have a plus here. We have 0 plus here. Okay, so it is coming from the right side of 0. So a approaches 0 from the right. Okay, now let's go ahead and evaluate that integral. Now let's proceed. We have the limit of a approaches 0 from the right. Now, what's the integral of 1 over u? Integral of 1 over u is ln u. Then evaluate that from a to 1. Then this is equal to the limit a approaches 0 plus ln of 1 is 0 minus ln of a. So know that ln of 1 is just equal to 0. So that means that we only have the negative ln a, and then we take the limit as a approaches 0 from the right. Okay, so this becomes ln of 0. Now, if you recall the graph of ln, this is your ln function, ln x looks like this. So now, if you look at ln x, as x approaches 0, from the right, where does the function approaching to? This curve goes to the negative infinity. So that means that as this a here approaches 0 from the right, your ln function, this ln x here, approaches negative infinity. So that will just approach to negative infinity. So in other words, this is equal now to the negative because of the negative sign here. And then this ln a here becomes negative infinity. So that's negative infinity as a approaches 0 from the right. So this is equal to positive infinity. Then that means that the integral diverges. All right, question number 2. We are asked to evaluate the integral of x f prime of x dx from 0 to 1, given that f of 1 is 7, f of 0 is 6, and the integral here of f of x from 0 to 1 is equal to 5. Now, if you examine the problem here, we don't know what this function here, but we are given the derivative of that function f of x. And also, you're given the value of f of x when it's evaluated at 1 and at 0. And the numbers here, the 1 and the 0, are actually the limits of integration for this integral here. And we also have this. So this suggests that we actually have to use integration by parts. Because if you do integration by parts, if you would let this as your u and this expression here as your dv, why would this be your u and why would this be your dv? Now, because your dv needs to be integrated, so we would have to use something that we can integrate. That's the derivative is already given, so when we integrate it, it's just the antiderivative of the function, so it's just the function f of x. And then the u here needs to be differentiated, so the derivative of x is equal to dx. So that kind of works. So let's see. If I let u be equal to x and my dv is equal to f prime of x dx, then the du is just equal to dx. And the v is just the integral of f prime of x dx. And the integral of that is just equal to f of x. And so therefore, if we try to solve this, the integral from 0 to 1 of x f prime of x dx, using integration by parts, that is just equal to uv. So that means you multiply x and f of x. So that's your uv. So that's x f of x. Again, this represents your, let me write that down. That's your u and this is your v. Minus the integral of v du. So what is your v? Your v is f of x. And your du is just dx. And don't forget the limits of integration. So we would have to evaluate this from 0 to 1. And then this integral is from 0 to 1. All right, so now we're ready to evaluate. Okay, so let's evaluate this part here. That means we would plug in 1. So you have 1 f of 1 minus, and then evaluate 0. So you have 0 f of 0 minus the expression here, and that is just given to be 5. So you replace that by 5. And also f of 1 is given to be 7. So you just have 1 times 7. Now this becomes 0 because 0 times 6 is just 0. Then you copy the minus 5. So you have 7 minus 5, and that is equal to 2. That's letter C. And now let's move on to question number 3. Here we are asked to evaluate the integral of the square root of 1 minus sine squared t dt from pi over 2 to pi. Now to solve this, we will have to first apply an identity to 1 minus sine squared t dt. So if you recall, we have cosine squared t plus sine squared t is equal to 1. So that means if I move sine squared t to the other side of the equation, 1 minus sine squared t is just equal to cosine squared t. So that makes this expression here equal to cosine. So that means that cosine squared t is equal to 1 minus sine squared t. And then we have the square root. So we have the square root of cosine squared t. Now, you have to remember the definition for the square root of x squared. So whenever you see something like that, that means it is the absolute value of x, the square root of x squared. It's not x, it's not the principal square root, it's just the absolute value of x. So in other words, this expression here would become the integral of the absolute value of cosine of t dt. And that's evaluated from pi over 2 to pi. Now, this would also mean, so you could take out that absolute value as well. So you can have the absolute value of pi over 2, integral of cosine of t from pi over 2 to pi dt. Okay, so the integral of cosine t is equal to sine t. Okay, so you can do sine t and then evaluate that from pi over 2 to pi. Evaluate that and then you just take the, the absolute value, the answer, the absolute value in the end. Okay, so this is equal to the absolute value of sine of pi minus sine of pi over 2. Evaluate the, okay. Now, what is sine of pi? Sine of pi is 0. And then sine of pi over 2 is 1. So you have minus 1. So that means you have negative 1, but the absolute value of negative 1 is 1. Now let's proceed to question number 4. In this number, we are asked to evaluate the integral of 1 over x cubed dx from 0 to 1. Now before you proceed, looks like this is very, very easy, correct? So that means that you really have to be very careful, and before you proceed, you examine whether there are points on the limits of integration or in between that will make the function undefined. Okay, so what you would do is, for instance, 0. Plug that in here. You will have 1 over 0. That makes it undefined. If it's 1, you plug it into x, you have 1 cubed, that's 1, so that is just 1. So it's fine. So that makes that this 0 here makes the expression here undefined. Then you have to remember that that is an improper integral. So if it's an improper integral, the way you would have to compute it or solve it is to, use that definition. So you make this constant here, the one that makes your denominator equal to 0, be a variable. So for instance, I will make that b. And then you copy everything else. So 1 over x cubed dx. And then you have to write the limit of this constant as that constant approach to, or this variable here, that b, as that b approach to the number here. Okay, that approaches to 0. And that is from the right, because that is in between. The b is coming at the right side of 0, because the interval is from 0 to 1. So 0 from the right. And then you're now ready to evaluate this. So to evaluate this, you will just have to evaluate this integral as usual. So you will have limit b approaches 0 plus, and then integrate 1 over x cubed. Now to integrate that, you would have to rewrite this as x to the negative 3. Copy the limits of integration. Okay, so the integral of x to the negative 3 is just x to the negative 2 over negative 2. Evaluate that from b to 1. Copy the limit. Limit b approaches 0 plus. And then plug in values. So you have limit b 0 plus. You will have 1 1 to the negative 2 over negative 2 minus b to the negative 2 over negative 2. Or you could actually take out that negative 2, right? Okay, so anyway, let's just simplify this if you want to. So this would be limit b approaches 0 plus. Now, 1 to the negative 2 means 1 over 1 squared, and that is just equal to 1. So this first term here is just negative 1/2. Then now, because of negative, double negatives here, negative, negative, that second term is positive. Then loss of exponents. If the exponent is negative, you want to make that positive, you have to bring down the expression here and change the exponent to positive. So that makes it 1 over 2b squared. Okay, then evaluate the limit. So you have, you will have 1 over 0. What is 1 over 0? That is infinite. So that's infinity. 1 over 0 is undefined. This goes here to infinity. So you have negative 1/2 plus infinity is just equal to infinity. So this means negative 1/2 plus infinity, because infinity is very large. So this negative 1/2 here would not matter. So this is just equal to positive infinity. So the answer is letter D. It diverges to, that's negative infinity. It diverges to positive infinity. Number 5, you are asked to evaluate the definite integral of the square root of x sine cube x dx from 0 to pi over 2. Now, as a word of caution, just remember in the test, you may be just asked to evaluate the indefinite integral. So sometimes it's definite, sometimes it's indefinite. So as you see here in the exercises, you would see mostly definite integral because there's like an added step. But on the test, it may be just an indefinite integral. Okay, so you do really make sure that you know how to do this. Okay, so let's proceed to this number. Now, whenever you have sine cosine, this is on trigonometric integrals, you look at the expression with an odd power. Okay, and since in that case, this will be sine cube x. This one, the power of cosine is 1/2. So that's a fraction. So again, you look at the expression that has an odd power, and what do you do with that expression? You will have to factor out that expression. So this sine cube x dx here, or sine cube x, will be factored out as sine squared x sine x dx. And then you copy that cosine. Now, what's the goal? Why do we need to factor out the sine cube x? Because we can then write the sine squared x in terms of cosine. Okay, then you may write that sine squared x in terms of cosine, that is equal to 1 minus cosine squared x. That is for your sine squared x. Then here, the square root of cosine x will just be, square root of cosine x, because that's already in terms of cosine. And then you just copy this. So you have sine x dx. Then the reason for that is because we want to do u substitution. Then we can let u be equal to cosine. Let u be equal to cosine x. And then if you let u be equal to cosine x, your du is equal to negative sine x dx. Okay, so therefore this expression here, that square root of x, becomes u to the negative 1/2. So therefore this becomes, no, not negative 1/2, u to the 1/2, or square root of u. Okay, square root of u is u to the 1/2 times 1, you copy 1, and then cosine squared x, since u is cosine, this becomes u squared. So minus u squared. And then the negative, then the sine x dx here is just negative du. So you move that negative sign to the other side of the equation. You get the expression for sine x dx. So that will just be your negative du. Then, now going back to the problem, let's go back to the problem. The problem here will then be you can put the negative sign outside. Negative u to the 1/2, 1 minus u squared du. And then you change the limits of integration. Change the limits of integration. Now, how do you do that? All you need to do is, coming from your u here, you will plug in these values of x. So you will have cosine 0 at the bottom, and then cosine of pi over 2 as your upper limit of integration. Then you evaluate that. What is cosine of pi over 2? 0. Cosine of 0 is 1. So this becomes 1, 2, 0. Now, if that bothers you, you could flip this and then make it positive. If not, you can leave it like that. It doesn't matter, right? Okay, but it bothers me, so I'll flip it. Okay, so if I flip the limit of integration, I would have to negate the integral. So that would take out my negative sign. So that makes it 0 to 1. And then now, I can distribute this to that parenthesis. So that becomes u to the 1/2 minus u squared times u to the 1/2. U squared times u to the 1/2 is u to the 5/2 du. Then integrate it. Okay, so you will have u to the 3/2. You add 1 to 1/2. That makes it 3/2. 1/2 plus 1 is 3/2. Divided by 3/2 minus u to the, you add 1 here, that makes it 7/2. 7 over 2 divided by 7 over 2. Then evaluate it from 0 to 1. Okay, so this becomes 2/3. Get the reciprocal of the denominator and proceed to multiplication. 2/3 times 1 to the 3/2. That is just equal to 1. Okay, or so you won't actually be confused. I'll just plug in 1. Let's see, 1 over 3/2 minus 1 over 7 over 2. And this one is just the reciprocal of 3/2. That is the same as 2/3. And then here, reciprocal of 7 over 2, that means 2 over 7. And then you simplify, okay? Simplify this, you have 21, you have 14 minus 6, and that is equal to 8 over 21. Going back to the answer choices, that is letter C. let's proceed to question number 6. We are asked to identify the appropriate substitution to use when evaluating this integral. So when doing this type of problem, this is on trigonometric substitution, it is important that you identify the two identities that we're actually using in trigonometric substitution. And those identities are just the sine squared theta plus cosine squared theta equal to 1. And the other one is tangent squared theta plus 1 equal to secant squared theta. And from there, you kind of see which substitution you would have to use. And how do you do that? The goal, you make sure that the goal is to actually remove the square root. So you want to remove that square root because that makes it hard to integrate. And how do you do that? When you remove that square root, to remove that square root, you should have like a u, this is your u, minus a constant. So from here, if I'm going to move cosine squared to the other side of the equation, I will have a constant here minus a variable. Okay, so, and the same way also for sine squared. So that makes it actually the second identity, because if I'm going to, I already have here a u squared. I already have here a variable. So that means if I'm going to move this 1 here to the other side of the equation, I will have tangent squared theta equal to secant squared theta minus 1. So that kind of, that would be what I'm going to use here. Because if I'm going to let this x here be equal to secant, so if I have x be equal to secant theta, then x squared is just equal to secant squared theta. So I will have secant squared theta minus 1 on this, on inside the radical here, so on the radicand here. And then that would make this equal to tangent squared theta. So I'll have the square root of the square root of x squared minus 1 will just be equal to the square root of secant squared theta minus 1. Now secant squared theta is just tangent squared theta. So you will have tangent squared theta. That gives you tangent theta. So your x, therefore, is just equal to secant theta. Let's have question number 7. We are asked to evaluate the integral by completing the square. Using the completing the square method in the denominator, to do that, you just have to get the coefficient of x. And then the coefficient of x here is 6. Then you take half of that. Half of 6 is 3. And then you square it. The square of 3 is 9. That number is what you are going to add and subtract in the denominator. So essentially, you're just adding 0. So in this case, your x squared minus 6x plus 10 will just be x squared minus 6x. And to make it a perfect square, you would have to add 9. So that is the 9 here. Then the remaining, the plus 10 minus 9 will be your constant. And that is just equal to 1. So you have x squared, this part here, that is a perfect square trinomial, and that will just be x minus 3 quantity squared plus the constant here, 10 minus 9 is 1, plus 1. And so therefore, this integral here becomes the integral from 2 to 4 of 2 dx all over. Then rewrite the denominator. we write the denominator as x minus 3 quantity squared plus 1. Now to solve this, we will have to do u substitution. You would have to let u be equal to the expression here, x minus 3. Because if you let u be x minus 3, your du is just dx. Now, when you do u substitution, you also make sure that you change the limits of integration. So that integral becomes the integral of 2, and then the dx is du all over u squared plus 1. Then change the limits of integration. Going back to our substitution here, we let u be equal to x minus 3. So what you would do is you plug in these values of x here to x here, and then compute your new limits of integration. So to compute the new limits of integration, we first substitute x by 2. So the lower limit will be 2 minus 3, which is negative 1. So you will have negative 1 in as a lower limit of integration. What about the upper limit of integration? You would have to replace the x here by 4. So you will have 4 minus 3, and that is equal to 1. So you have negative 1 to 1. Then now you can integrate. Okay, so what's the integral? The integral for this is, so since you have u squared plus 1 in the denominator, that is just like tangent inverse. Okay, so what you could do is you take out the 2, look at it like that, negative 1 to 1, 1 over u squared plus 1 du. And what is the integral here? That is just tangent inverse of u. So this is equal to 2 tangent inverse of u. Evaluate this from negative 1 to 1. And that is equal to 2 tangent inverse, parenthesis 1, minus tangent inverse of negative 1. Now, what is tangent inverse of 1? That's pi over 2. Tangent inverse of negative 1, negative pi over 2. So you have pi over 2. This becomes plus, minus minus is plus. So pi over 2 plus pi over 2 is equal to pi. So this makes it 2 pi. That is letter D. Number 8, evaluate the integral x e to the negative x dx from 0 to 1. This is on integration by parts. How would you know if it's integration by parts? You normally use that if you have a product of two functions. One is differentiable and the other one is integrable. In this case, both of them are, differentiable, integrable. So you just have to choose which one would make it a little bit easier. So here, in this case, you would have to let u be equal to x, and your dv is equal to e to the negative x dx. Why did I choose that? Because if I'm going to differentiate x, that will just make it a constant. But if I'm going to integrate x, that will make it x squared. So that will make my expression be more complicated. So the natural choice is to make your x, your u, the one that you're differentiating. Okay? So if you differentiate u, you get dx. And then to get v, you will have to integrate e to the negative x dx. And the integral for that is just negative e to the negative x. Then after that, you can apply integration by parts. Integration by parts using the formula is uv. So this integral here is just equal to uv, that is x e to the negative x, and there's negative sign here too. So that makes it negative x e to the negative x. So that's your uv minus the integral of v du. So this is your v. V is that. So there's a negative sign outside, the integral of v du. So e to the negative x dx. And then don't forget the limits of integration. The limits of integration is 0 to 1, 0 to 1. Now let's rewrite that. So we have, before, you just have to pay attention. This double negatives here makes it positive. Now let's evaluate it. You plug in 1 here, so you have negative 1 e to the negative 1 minus 0 plus the integral of 0, 1 e to the negative x dx. And what's the integral for that? The integral of e to the negative x dx is just negative e to the negative x. So this is equal to negative 1 over e. That's the first expression, the negative sign here. And then e to the negative 1 will be in the denominator. Plus, what's the integral here? The integral of e to the negative x is negative e to the negative x, evaluated from 0 to 1. Now again, this sign here makes it minus. So this is equal to negative 1 over e minus, and then you plug in e to the negative 1 minus e to the 0. And then we evaluate, remove that parenthesis. This is equal to negative 1 over e minus 1 over e. This is 1 over e. And then the minus makes it positive. Plus, and then e to the 0 is 1. This is equal to negative 2 over e plus 1. Negative 2 over e plus 1 is this expression here, letter A. Number 9, let's evaluate the given integral. So in this example, we will have to use integration by substitution. You would have to let u be equal to ln x, and so therefore your du is equal to 1 over x dx. This means that this x dx here will just be your du. Now also pay attention that this is a definite integral. So that's a definite integral, meaning you have to also change the limits of integration here. You do that by evaluating the expression here with the given values of x, or with the old limits of integration. So to compute for the new lower limit, limit of integration, we have ln of 1, and that is equal to 0. ln of 1 is 0. And then the upper limit of integration will be ln e, and ln e is just equal to 1. So that means that this integral here will just be from 0 to 1, and then this dx over x is just du. So that is your du. The denominator is the square root of 1 minus u squared. All right, 1 minus u squared. Now, if you go to your formulas, the list of formulas, you would be able to recognize that you have a formula for this. And the integral for this is just sine inverse. That is just the sine inverse of u. Evaluate this from 0 to 1. What is sine inverse? And then you have sine inverse of 1 minus sine inverse of 0. Sine inverse of 1 is pi over 2. Sine inverse of 0 is 0. So that gives us pi over 2. Letter C. Number 10. Evaluate the integral cosine cube x dx from 0 to pi over 6. Again, let me remind you, on the exam, you would see several questions that are also indefinite integral. That means it does not have limits of integration. But I just chose to solve integrals with limits of integration so you also get used to it. Okay? All right, so number 10. How would you evaluate this? So since you have a cosine function here and it is raised to an odd power, the technique for that is to factor. So you would have to write this as cosine squared x cosine x dx. The reason why you want to factor that is because you want to express this in terms of sine. So this other factor here is actually your du. You would express this as 1 minus sine squared x. And you will have cosine x dx. So in other words, if you let u be equal to sine x, your du is cosine x dx. That means that the expression here would become, this expression here will just become 1 minus u squared, and then your cosine x dx is just your du. So times du. Now, because this one here is a definite integral, that means you also have to change the limits of integration. Change the limits of integration. So to do that, you would just have to plug in these values of x here to the x here. So from this definition, you compute your new limits of integration. So you do sine of u. So the lower limit is sine of 0. And what is sine of 0? Sine of 0 is just 0. Then the upper limit, sine, copy sine, and then you plug in pi over 6. Sine of pi over 6. And what is sine of pi over 6? Sine of pi over 6 is 1/2. And so you have 0 to 1/2 as your new limits of integration. Then you can proceed to compute for the given integral. Okay, so to integrate this, you will have the integral of u is the integral of 1 is u. The integral of u squared is u cubed over 3. Then evaluate that from 0 to 1/2. Then you plug in. So you have 1/2 minus, you get 1/3, and then 1/2 cube. 1/2 cube. That's your numerator. Minus 0. Okay. Then this is just equal to, all right, if you're confused with that one, you have u cubed, so that's 1/2 cube over 3. Okay, so you will have 1/2 minus 1/2 cube is 1/8 over 3. So that is 1/2 minus 1 over 24. And this is just equal to, you multiply 12 on both numerator and denominator. So you will have 12 over 24. So that means 12 minus 1 over 24. That is 11 over 24. 11 over 24. Number 11. The best trigonometric substitution for integrating this integral is, then you just have to pick. As I've said, when you're solving something like this, your goal is to be able to remove this square root sign here. So that means you want to apply a trigonometric identity so that this will just be, the radicand here will just be equal to a single expression. And in trigonometric substitution, we only have two choices. So you have one, you can have cosine squared theta plus sine squared theta. And then you just have to manipulate this, is equal to 1. The other one is 1 plus tangent squared theta is equal to secant squared theta. Now, we have a constant here. Okay, so if we have a constant, right, we have a constant, that means that we have to pick this. So that means we constant, and then this is a variable. So the variable would be either sine squared or cosine squared. So in this case, we will actually move that sine squared. So notice that if I'm going to move the sine squared theta to the other side of the equation, cosine squared theta is equal to 1 minus sine squared theta, right? 1 minus sine squared theta. And then this one will just be, x will just be my sine squared theta. But notice that if I have x as sine squared theta, then I will have a sine squared theta here. But you have 4 here. 4 minus sine squared theta is not equal to cosine squared theta. So what do? You also want a 4 here as well. So what you want is actually that x there, you want a 4 sine squared theta. Okay, so you want a 4 sine squared theta there so that you can actually factor out that 4. So if you factor out that 4, see, if you factor out the 4, you will have 1 minus sine squared theta. Then you're able to cancel the square root. So you will have the square root of 4, and 1 minus sine squared theta is cosine squared theta. In that case, that square root would cancel out. This would be equal to 2 cosine squared theta. All right, so that is what we're looking for. See, again, the goal is to be able to remove the square root. So we want the radicand to be a perfect square. Okay, so going back there, if this is what we're trying to accomplish, this is what we're trying to accomplish. We want that x squared to be 4 sine squared theta. So you want the x squared to be 4 sine squared theta. That means that would imply that x is just 2 sine theta. And that is letter B. Now, next question. After making the substitution, so in this case, this is in relation to question number 11. After making the substitution you chose in the previous problem, that is in problem 11, the integral that you obtain is, okay, so there would also be a question like this. So after making an appropriate substitution, so look, given something like this, you're asked to make an appropriate substitution. That means you have to think which substitution you would have to use. And then you set up the integral that you would solve. You don't need to solve it completely. You're just going to look how the integral would look like. Okay, so we already have solved half of it. We know the integrand will just be equal to 2 cosine squared theta in the end. Now, going back here, if you let x to be equal to sine 2 theta, so if you let x be equal to 2 sine theta, your dx is just equal to 2 cosine theta d theta. So that means that your problem here, this expression becomes the square root of 4 minus x squared dx. Is just equal to, okay, so the integrand, the square root of 4 minus x squared, the integrand becomes 4 cosine squared theta. Now when you take the square root, that is equal to 2 cosine, oops, there should be no square here, 2 cosine theta. So that is 2 cosine theta. And then the d theta, the dx here will be replaced by this. So times 2 cosine theta d theta. So this makes it equal to 4. 2 times 2. 2 times 2 is 4. Integral of cosine squared theta d theta. So let's look for that. Oops. Okay, so that's letter E. Okay, number 13. That's on partial fraction. The correct partial fraction decomposition of this expression is, then those are the choices. Now, before you proceed, you make sure to look at compare the numerator and the denominator first. If in case the degree in the numerator is bigger than the degree in the denominator, then you have to divide it first. Divide it using long division. But if, like in this case, the degree in the numerator is already less than the degree of the denominator, then you can proceed and decompose it into partial fraction. So decompose it as partial fraction. Your denominators will be each of these. Okay, so you will have this as your denominator and then this also. But notice that you have a power here. That means that this factor is repeated. So that means that you are going to have this to the power of 1 and this expression to the power of 2. So if you look at this, if you are going to eliminate those that cannot be like an outright wrong answer, it will be this one is wrong, this one is also wrong. That's not an answer. Now we're left with this 3 here. Look at the denominator. So it should be x plus 3. Yes. And then you have this to the power of 1. That's correct too. And to the power of 2. Good. Now, what about the numerator now? So you would look at the denominator. If the denominator is linear, the numerator is constant. So those are all good. But then, for the denominator here, this one is quadratic. That means the numerator needs to be linear. Here, that is already constant. Both of them are constant. So that's not an answer either. Here is linear. And also here needs to be linear. This one is just constant, right? So that means not an answer as well. So the correct answer is letter D. Okay, number 14. Partial fraction decomposition for this. Again, double check. The degree in the numerator is 2. Degree in the denominator is 3. We're good. The degree in the numerator is less than that of the denominator. So we go ahead and decompose this. Our denominators will be these factors here, x plus 1 and x squared plus 1. There's no multiplicity. So therefore, we don't need this. So that would be incorrect. And this one, E, is also incorrect. So we are left with choice A, B, and D. All the denominators are good. Those are the factors of the denominator here. So first we have a linear. If it's linear, the numerator should be a constant. Then next we have quadratic. The numerator, if the denominator is quadratic, numerator should be linear. So letter A is correct. That's the answer. Here, it's incorrect because this is constant and this is quadratic. That's incorrect. And this one is linear, but this is also linear. So that makes it incorrect as well. Okay, so letter A is the answer.